In this video, we will explain how to enable GPIO support in Linux with Yocto and use a proper driver to control GPIOs. In order to enable GPIO support, we have to reopen Linux menu config with Yocto. Let's go to our Yocto folder where we previously built the development image and launch the setup script. Now we can type within the build folder machine equals icicle-kit-es bitbake-c menu config virtual /kernel. In the Linux kernel menu config, we can now enter the driver menu. Go into GPIO support and enable the sys GPIO support. We save the new configuration and exit. At this point, we have two options to rebuild. The first is to force the compilation with a new configuration with the -c compile-f command, and then rebuild. However, this way won't make our changes persistent, and we will need to apply them to the configuration every time before building. To avoid this, it is better to create a configuration fragment to be added to the kernel recipe to better maintain the code. Let's create the configuration fragment by typing bitbake mpfs-linux-c diff config. Now, we copy the fragment just created in the kernel recipes files folder. meta-polderfire-socdash-bsp/recipes-kernel/linux/files/, renaming it as sysio.cfg. Then we edit the kernel recipe in the upper folder mpfs-linux_5.%.bb by appending the fragment in the src_url variable relative to our machine. We can now build with the usual command. Machine equals icicle-kit-es bitbake mpfs-dev-cli. Once the image is ready, we can reprogram the eMMC and reboot. At the Linux prompt, we can pipe grep to dmsg to verify that the GPIO driver has been correctly probed. Let's also understand where the GPIO driver is configured in the device tree file. If we go back for a while in our Yocto folder, we can find the device tree in meta-polderfire-recipes-kernel/linux/files/icicle-kit-es. Here we can see how the driver is linked to the GPIO mapped address, interrupts, and clocks. Now we can move in the sysclass GPIO folder. We can ask the kernel to export GPIO 16 to the user space. And now we can switch on the LED by redirecting echo 1, and we can switch it off by echoing 0. The same procedure can be applied programmatically with an application, as the one you can find in the apps repository on the MCHP GitHub webpage. Within the apps repository in the Linux_examples folder, you can find the Linux image with GPIO sysfile system enabled, an LED_blinky.c application, and its precompiled binary. Let's clone the repository and recompile the source code directly onto the board. This source is already available in the image in the apps repo. We are using it just as an example. To do this, we need to transfer the C code to the Icicle kit. We have two options. One is to use Ethernet cable with a protocol like Secure Copy, or we can use the serial port. Let's see how we can do it with the serial port. We can use the Z modem protocol and the Terra Term Terminal emulator that integrates this protocol seamlessly. We also need to install an additional library, LRZSZ, in our image because on the Icicle kit we will run the receiving endpoint of the protocol. We can append it in the core image extra install variable in the conf/local.conf file and rebuild. Since we are using Mobax term, we temporarily disconnect the serial console there and we open Terra term. We configure it with the right COM port and the right baud rate of 115200. We then verify that the connection is okay. Then we go to File, Transfer, Z Modem, Send, and select the LED blinky.c file, which is sent to the board. Now we can compile a file directly onto the board using GCC provided by our development image. We run the application and can switch LEDs on with that. There is also a new way to control the GPIO available since kernel 4.8. The GPIOs are exposed as char devices in the dev folder and are described using proper descriptors. This new and more robust implementation does not allow to manipulate GPIOs directly from the command line by directly writing a file. We can use libgpiod to control them. With GPIO info, we can retrieve information about available GPIOs and control them using a GPIO set command. In our next video, we will explain how to control a basic fabric IP like LSRAM with user I/O drivers and how to cross-compile an application on the host with Yocto.